Okay. Huh? Yeah, because you're filling mine too. So, I don't like to lump spheres in with prisms and pyramids because they are very different things. A sphere does not have a two-dimensional representation. You cannot draw it as a net like you can with prisms and pyramids. So I give them their own thing. And because you can't draw it like a net, it makes it really difficult to explain where we get the formulas. So even though I always tell you why things work, for spheres, I don't bother because it's a super pain in the bum. I'm just going to go straight to the formulas, okay? But you guys are smart kids. Obviously, you recognize that since the sphere is just a bunch of circles spun around infinitely around a center point, you know that pi r squared has to be involved with everything because pi r squared is involved with everything with circles. So there's the two formulas. They're easy peasy. I don't need to spend a lot of time on them because you guys already are aware of how those things work. However, in the blank space at the bottom here, I do want to talk about the ramifications of these two formulas, okay? We're going to start with the first one, the surface area, not of a sphere, because that's real easy. I want to talk about a hemisphere. What is a hemisphere? Half a sphere, absolutely. So what am I going to do to this sphere if I want to have a hemisphere? That all disappears. Agreed? Now, before I erased this black line from the bottom, was that circle surface area? Why? Because it was inside the sphere. Yes? Now what is it? Part of the surface area. It's outside the sphere now, isn't it? Yeah. So, when I ask most classes, what's a hemisphere? One person in the class at least says, well, it's half a sphere. Okay, so what's the formula for the surface area of a hemisphere? And they all go, okay, well, it's 4 pi r squared divided by 2. Right?
No,
of course not. Because you have to add the circle that you created. So it is 2 pi r squared plus, what's the circle? Pi r squared, so what's the answer? 3 pi r squareds is the surface area of a hemisphere. Yeah? Yeah, excellent. Now, the volume of a hemisphere, most students I teach do not like that formula. Why? It's got a fraction. You guys are like, fractions, bleh. I don't understand how they work. So we write them, you can write it another way. 4 pi r cubed, all divided by 3. Okay? I don't care which one you use. But again, volume of a hemisphere changes, right? What's a hemisphere? Oh, I forgot the P. That's a hemisphere. Hemisphere. What is a hemisphere, Lauren? Half a sphere. So the volume is 4 pi r cubed over 3. What? Divided by 2. Barf. What's the better way to write a fraction divided by 2? Right. This down here is the same as times 1/2, yes? Okay. 1's in the numerator, so what happens to the numerator in our formula? Stays the same, 4 pi r cubed. Oh, that's a new one. I like it when new problems happen with my computer. Just when I'm getting used to the old ones. And what's the bottom? 6. So that is our formula for a hemisphere's volume. And that is our formula for a sphere, hemisphere's surface area. Does everybody see what has happened there? Now let me ask you this. Theoretically speaking, if I had a hollow sphere and I cut it in half, what would be that hemisphere's surface area? Talk amongst yourselves. Go. I'm drinking my water. I must ask you to figure it out for yourself. All right. Who has an answer for me? Wait. Armand. Okay, I have one. It would be the same as the original sphere. Excellent. Because once you cut it in half, then all that is surface area inside. Yeah? Excellent. Okay, what else we got? Everyone agrees? Byron. If I dipped it in paint, is the inside exposed? If I had a basketball and I dipped it in paint, would there be paint inside? Painted the inside of a basketball and then put it together. Theoretically. Not sure I'm picking up what you're putting down there, my friend. Not sure if I agree 110% with your police work there, Byron. But I understand what you're saying. I do. But no, of course not, because the sphere is a closed thing, right? Does anybody disagree with what Armand said? You'll be exactly the same? She has to make one assumption. What is her assumption? Blake? That there is no thickness to the wall, yes? Because theoretically, the surface is two-dimensional, isn't it?
Yeah.
Right? In theory. But it's not, is it? So it's going to be almost the same. But in reality, for example, if I made a bowl that was hemispherical, there's the outside, which is green, the inside, which is blue, but there would be this little lip here, wouldn't there? Yeah. In reality, from a purely theoretical math standpoint, whereby the outer shell was indeed only two-dimensional, it had no depth, then of course the answer would be exactly the same.
That's what we said.
You sound like you're going to punch him in the mouth, Jamal. Relax, Manalo. It's math class, man. Stay cool. Holy. Math bullies. Did I tell you guys the nerdy discussion from the Star Wars store yet?
No.
Back to business. Small little gap when you watch the video. We stopped at like 12:09 and now it's 12:13.
Sam just missed out on a great conversation.
I know, and I didn't record it for him.
He'll never know.
Tomorrow we should say everything is lukewarm and we can laugh and Sam he'll go ape. He'll be sitting right there. Oh my God, why are you all laughing? Tell me why you're laughing! Emily, tell me why you're laughing! Ah! He heard that. He's already going to start. You guys are all going to get sometime around 8 o'clock tonight. You'll all start getting tweets and Snapchats and what happened in England today? Mr. Myron making fun of me. I know he will, because he will not be able to accept the fact that we were talking about him without him here. And he has no idea the last 4 minutes are gone. It's like that trick on the cooking show where they put in the uncooked lasagna and pull out the cooked lasagna. Because they don't want the cooking show to wait an hour while the lasagna cooks. Oh man, my daughter made me do this thing with her hair where you tie a bunch of knots in it with rags or some crap.
Why? Because it makes it all curly.
Yeah. What a giant pain in the ass that was.
Did you use toilet paper?
No, I used to cut up a dish rag.
Oh, okay.
I mean, it made her hair look cool, but oh, it was a pain. All right, here we go. Number one here, this is a math class problem. Yes? Because, of course, you would never wrap a basketball as a sphere. You would either deflate it and roll it into a tube and wrap it, or you would leave it in the box that it came in, which is rectangular. You would not bother wrapping it as a sphere. Kind of easy to guess what it is. But you could really you could mess with somebody's head by giving them a sphere, and they'd be like, oh, you got me a basketball, huh? You're like, and you gave them a globe. Or something like that. You laugh. I have a globe that lives on a shelf right by my dining room table. And you have no idea how often that globe comes into play at dinner time.
What kind of globe is it? Like you shake it and it snows?
No, it's a globe. The world.
I thought you meant a snow globe.
No, a globe.
No, I understand. It's okay. No, I get it now.
All right.
Once I wrapped a globe for my friend for her birthday.
My wife gave me a steering wheel cover for my birthday because she knew we were planning to drive to California in the summer. And she wrapped it round, and I was like, I don't really know what that is, nor do I really care. But my buddy was like, hey, nice steering wheel cover. I'm like, dude, I haven't even unwrapped it yet. And it was a steering wheel cover. All right, so this question, normally we use the formula to find the surface area. But we have practiced that so much, I am using this question to actually practice your algebra because you know how to do a formula, right? So since we're dealing with the surface area, because why is it the surface area? Because wrapping paper goes around the outside of the basketball. So I must be doing surface area of a sphere, which is 4 pi r squared. Now, normally, we would be given the radius and we would be finding the surface area. But like I say, we have practiced that to death. I know you can fill in formulas. I have to remind myself if you can indeed do algebra before we go too much further. So let us, cabbages, practice our algebra. What number do we have? We have the surface area. Where do we write that?
In the surface.
In the surface area, 2,500 equals 4 pi r squared. Now, what is your job?
You have to isolate the variable.
Isolate the variable by doing what?
Divide 4 and
Why is it dividing by?
because it's multiplied.
Because in the equation it is multiplied. So we are going to divide by what? 4 pi, which means what happens to that 4 pi, that 4 pi, that 4 pi, and that 4 pi? We eat them, and we're left with r squared. What happens on this side?
Divide by 4 pi.
Divide by 4 pi. Now, here we are in a bit of uncharted territory, because there's two things you could do here. One, you could find that number, right? Which is doable. How would you find that number with your calculator? What would you do? Who would like to volunteer the buttons that they would push? Kayla, hit me.
Okay. 4 times pi.
Yes.
So you get that.
Yes.
And then you do, like, remember that number and then 25.
Remember that number. How?
Or, like, write it down.
So you would go
I know what
4
I'm just-
times pi, and you would write that down?
No, I know.
Okay, and then what?
And then, like, you have
Then you would push clear,
clear. Yeah. And then 2,500 divided by
2,500
Yeah, divided by
divided by, oh, I didn't write it down.
Well,
Damn. Amshman, what would you do?
Okay, there's two ways you can do it.
Amshman, I only want one.
Okay, 2,500 divided by
2,500
divided by 4
divided by
4
4
pi. Second function.
second function pi.
But then you can also do 2,500 divided by 4 times pi, which is
Okay, so Amshman says that's the answer. Right?
yeah. No, that's equal to r squared. But yeah.
Amshman,
Yeah.
that answer on the screen, does that make sense?
No.
Of course it doesn't.
No.
Because that answer on the screen says 2,500 divided by 4 pi. 4 pi is at least 12.
Never mind.
2,500 divided by 12 isn't 1963.
Yeah.
So, again, reasonableness of answer. Amshman believed his calculator. I had to point out that that couldn't possibly be right. Lauren,
I would do 250.
2,500. Yeah, I get you.
500
Yes.
Divided by, in
Bracket
pi.
4 pi. Because what Amshman has done here is he has told his calculator to do 2,500 divided by 4 and that number times pi. Because his calculator does BEDMAS. Your calculator only does what you ask it to do. Okay? Everybody with me?
Yeah.
So you could get that answer the way Lauren got that answer, which is fine. Of course, it would be 2,500 divided by bracket 4 pi, close brackets. Much nicer, yes? Now let's stop for a moment here. That you dropped something from your hand and it caused you to rub your head. Okay, yep, no, makes perfect sense to me now. No problem at all. Now here's the problem here. I've done the work, right? Now, of course, Amshman would never have made that error in real life because before he ever touched his calculator, he would say to himself, self, that's 2,500 divided by, pi's about 3. 4 times 3 is 12. 2,500 divided by 12. I must need an answer of around 200, which is, of course, what he would have done. So when he got 1963, he absolutely would have stopped and fixed it. Right?
Yeah. Yeah.
Of course he would. The thing I'm trying to say here is we also then would need to square root that answer, right? So I can also square root that answer and then square root that. And this is a perfectly acceptable answer. Okay? Because that shows me the math. However, it's pretty difficult for you as a real life person to say, well, the radius of the basketball is the square root of 2,500 divided by 4 pi. How big's that basketball? Anybody know? You have no idea because that number means nothing to you, does it?
29,
Does that number mean anything to any one of you?
No.
Show me with your hands a radius of 2,500 divided by 4 pi square rooted.
That's not a radius.
Exactly, right? So that number actually means nothing to you. Is it mathematically correct?
Yeah.
Yes, it's what we like to call an exact answer, but it's not a useful answer. So we would get the useful answer. Now, you could do this all in one go on your calculator, all right? It depends on your machine. It's up to you to figure it out. But what I want to show you, the point of this entire discussion, is to get you friendly with, if you don't have a calculator like mine that has a whole screen, a great many of you are using a calculator that has one line of business, yes? 5 times 2 equals, shows you 25, yeah? Then if you push another number, I said 5 times 2, didn't I? Yeah. 5 times 2, you push equals, it shows you 10, right? I heard myself. I was just hoping all of you would leave me alone. Obviously not. And then if you push another number, what happens to the 10? It goes away, right? So if we do Kayla's method of 4 times pi, as soon as you touch another number, that 4 times pi disappears, yes? Right?
Unless you do answer, like on some of them there's the
Why do you continually give me away? Spoiler alert, Taylor's in front of the room. The point I am trying to make is your calculator has a few functions that will help you out with that. One is the memory function, which is real pain in the butt to use because it's different on every calculator. But the other one is this function right here, ANS. If you can find the ANS button on your calculator, which is often a second function of equals, then that will tell you, it will bring back out of your calculator's memory the last number that you hit equals for. Do you understand what I'm saying? So pretend I have a calculator that doesn't show its whole screen. It only shows one line. So I do my work like Amschman. I do it properly this time. Divided by bracket 4 pi. I listen to my good friend Lauren, and I use brackets because they're our good friends too, and I get that. Now if I want to square root that, some calculators, I can just push the square root button, it'll work. But most of the calculators you guys buy now don't work that way. They allow you to punch in what you read because kids have gotten progressively worse at math over the years, and the guys who make calculators realize that if the question reads square root of 7, kids need to punch in square root 7, right? You know, the calculators when I was your age, you had to push 7 square root. They were backwards. So if you have a backwards calculator, it's no problem. You just hit square root. But since many of you have a forwards calculator, you're going to hit square root now, and your screen is going to be blank. You don't remember 198.94, blah, 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 blah. But if you have the answer key, square root of your last answer, and you get 14.1. Now, does that make sense? 14.1 centimeters. Oh, 14.1 centimeters. That's a radius. Double it. It's almost a foot. Hey, that's about the size of a basketball. Answer that makes sense, right? Now, when I gave this to my class this morning, I got answers of 3. I got an answer of 198 because that person forgot to square root. I got answers all over the place, including the right answer. But they all got to here. So what's the problem? Was it the math or was it working their calculators? It was working their calculators. Sadly, all of you consider working your calculator doing math. And that is indeed not the case, is it? Right?
No.
The math is done in your head. The calculator just does the work. Right? So please make sure as we go further and further in Math 10 and you use your calculator for more and more complex things, that you are always keeping in your head an idea of where you are going. So when your calculator gives you gobbledygook, you can say, "Ha, you're not fooling me, calculator," and you can fix it up. Everybody cool? Because this is not Calculator 10, pre-diploma. This is Foundations of Math and Pre-Calculus 10, pre-diploma. Okay? Okay. Let us move on. Next question. Also a math class question, because the real answer to this question is, who cares? But since you're all in math class, we're going to solve it, right? Before you put any numbers on the paper, what is this question asking you to do? Read it, think about it, tell me. Leighton.
The volume of the box where the ball is not taking up space.
So what math are we going to use?
We're probably going to use subtraction.
Subtraction, because we need the difference between the space that is filled by ball and the space that is empty, correct? Byron.
Doesn't the inside of the box have no volume because it's just empty space?
No. Volume is the amount of space that something takes up in the universe, yes?
Yeah.
Okay. So if there's... Is there something in there? Sure there is. It's not a vacuum. If I put my finger in there, it doesn't disappear. There's air in there, right? So does it have a volume?
Yeah.
You with me?
Yeah.
What you're talking about is capacity, which are two different things, right? Technically, the empty box has a capacity because it is empty and it can be filled up. This has a capacity. It does not technically have a volume. We use them interchangeably. Understand? For this to have a volume, technically, it would have to be solid. I hear what you're saying. So, no, it's all right. Just knocked my train of thought off.
Yeah.
Sneezed so hard, it was just trucking down the tracks, and now it's derailed. Leighton said we're going to do some subtraction. Before we put any numbers down, we should think about what exactly we are subtracting. What are we subtracting? Blake.
The volume of the three golf balls.
From what?
From
The
the
volume.
total volume of the box.
Right. So, but this is not math class, or this is math class. What's a box?
A rectangular.
Right. So we got a volume of a rectangular prism. We are subtracting the volume of what?
The ball. 3 balls.
Right. 3 whats? Balls is not the word. 3 spheres, yes?
Yeah.
So now let's put in some numbers. What's the volume of a rectangular prism?
Next time.
LWH, right? Or area of the base times the height. Minus 3 spheres. 3 what? 4 pi r cubed over 3.
Yeah.
Now, to punch this mess into your calculator, which is what 75% of Math 10 students will do because they won't take this step to show work. This is hard to punch in. What do us 25% of math students, who are all in pre-diploma and show our work all the time, what do we get to do with those 2 3s before we go to our calculator? Why?
Because if you're going to divide by 3 and then multiply by 3.
Right, they get to cancel out. Now, all of a sudden, I only have LWH minus 4 pi r cubed. Now, how easy is that?
Easier.
Right? So all those people that, hey, I show work, that's for stupid people. Why would I show work? My calculator does it all. Go ahead and punch that into your calculator and see if you get the right answer. While the rest of us take 1 second to write this out, cancel, and punch that into our calculator. Everybody picking up what I'm putting down?
Yeah.
All right. So what's the LWH?
3 by 3.
3 by 3 by 9. Not even going to punch that in my calculator. Why?
Because it's easy.
Because it's 81. Minus what? 4 pi. What's R?
1.5.
1.5. I didn't fool anybody. Cubed. Now, the question becomes, can I punch all that in one go?
No. Sure. Yeah.
How?
Okay.
Put brackets around the second half of the equation first.
So you could add those brackets. Do you need to? Why not? What's BEDMAS say you do first?
You have to do the exponents first.
BEDMAS says you're going to do times and exponents first, right? So even if you just punch that in, you're still going to get the right answer. But the brackets are useful. Why? Organization, right? So that's cool. Some of your calculators are going to need to push a button there and there. What button? Times. Some of your calculators won't. Who knows how your calculator works? You do. I can't tell you the right way to do it. What are you going to need to do there on your calculator?
Oh, the second part.
The exponent button. For some of you, it's going to be x with a little y.
And then sometimes
For
there's even like a pre-made cube one.
Yes, sometimes it's y to the x. Sometimes it's x to the blank. Sometimes it's this little mountain thing, which is called a caret. In this case, since it's cubed, some of your calculators even have an x cubed button, which you could use. Again, can I possibly show you every way to do it? Of course not. So whose responsibility is it to learn how to punch that in? Yours. But I show the work, right? So everybody go ahead and punch that in. Tell me what the answer is. What's the answer?
38.5 or 38.6.
38.58. I've heard 38.6, 38 point blah blah blah. Do I really care?
No.
No. If one of you handed me 38.6, one of you handed me 38.58, one of you handed me 38.589, one of you handed me 38.58975839727, you all getting the same answer? You all getting the same mark? Yeah. All right. Everybody good? Okay. Finish 34, 35, 36, and 37. Go diddly o. Please notice on the side of my notes here, what comes after lesson 1.6? Quiz. Will that quiz be tomorrow? Of course not. We haven't even gone over page 33 to 37. When will we be going over 33 to 37? Tomorrow. So when is your quiz? Thursday. What's it on? Everything that we have studied up till now is fair game, including conversions. Now, what will I do to you most likely? Will I give you a conversion question? No. But will I ask you to find me a surface area in centimeters after I've given you the measurements in inches? Maybe I will. Maybe it will. Maybe it won't. Maybe it'll be like a university multiple choice where the right answer isn't there and you'll just have to guess what's close. Maybe it'll be A to J.
Wait. There's university questions where there's no right answer?
Of course there is.
What are you supposed to do?
You do all the work like it was open-ended, and then you choose the answer on the page that is closest to your answer.
Right answer.
I know that.
Would you still get the right mark then?
Okay, Taylor, the point of these is because the way you guys get multiple choice in high school, it's A through D and the right answer is there. And then we give you unlimited time. So technically, you could try every single answer on the test back in the question, right? Because what do teachers do? Do we set time limits anymore? No, because what if little Johnny just needs a little more time? So what do we do instead? Who needs more time? Huh? Because in the real world, if I'm performing heart surgery and the person is about to die, I can go as slowly as I need to, right? Because I'll get a rewrite and the teacher will say, who needs more time to fix the heart? Right? Because in reality, deadlines don't exist. Obviously. Right? We only have a word for it. Deadline. Yes, I know. Right? What does deadline mean? That means if you cross that line, you are dead. That is why we have the expression. But in high school, do such things exist anymore? No, because then we're not assessing your knowledge. We're assessing your time management. And that's not fair to somebody with bad time management. They don't get a chance to show their knowledge. I know that. It didn't hurt me that I had deadlines growing up.
Stuff like that in